The Pythagorean theorem. Okay. Pythagorean. That's spelled right. It doesn't look right to me, but I'm gonna look. Yep, re-n. Re-n. Why is it re-n? Re-n theorem. If you had to guess who came up with this, it would be Mr. Pythagoras. Yes, Pythagoras theorem. Now, you've heard this before, maybe not. Maybe you've never seen this. And if you are easily frightened, maybe you don't want to watch this because in The Wizard of Oz, those little flying monkeys are there. But here, this, maybe you caught this, maybe you've seen this, maybe you haven't. From The Wizard of Oz, I have a short little snippet about the guy I think that wants the brain. Which guy wants the brain?
The robot.
The robot, yes. No, there's no robot.
Scarecrow.
Scarecrow.
The robot. No.
Somebody give me some lightings there. Ephraim, turn off the light. It's very short. Pay very much attention to this. We have to have our little disclaimer here. Little Metro Gold here. It's only about 20 seconds or so. It's not very long. Here we go. But Dorothy. The Pythagorean formula incorrectly stated by the Scarecrow. Ready?
The heart that you promised Tin Man, and the courage that you promised Howard. I'm Scarecrow. Why, anybody can have a brain. That's a very mediocre commodity.
I'm going to turn that up because I don't want you to have to stress. Everybody can have a brain. That's a very mediocre commodity.
Use the animal creature that crawls on the earth or slinks through slimy seas as a brain. Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D. Ph.D.? Yes, Doctor of Thinkology. Now, sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
In case you missed it, he gave it to you incorrectly. Okay, let's go back. He says the Pythagorean theorem.
The square root of
the sum. I'll see if you can figure out what it is. The sum of the square roots of two sides of an isosceles triangle.
Square angle is equal to the square root of the remaining side.
Is equal to the square root of the remaining side. Now, what's wrong with Mr. Scarecrow there?
He doesn't have a brain.
This here, the gimme lights there. His said, what type of triangle did the Scarecrow say? Isosceles triangle, and that's way off base because it's not isosceles. Pythagorean theorem is only, and write this in big letters, only with right triangles. And in words, if you were saying it, he said, well, actually, what did he say? Let me go back and see if I can get back. Wait, there was one. He said, wait.
Oh, John! Oh, I'm trying. So it's equal to the square root of the remaining.
He said, the sum of the square roots of two sides of an isosceles triangle.
Any two sides of an isosceles triangle is equal to the square root of the remaining side.
And that's not true either. Because what's really true about it is this. He said any two sides. You can't do that. It is this. The sum of the two legs of, oh wait, the sum of the square. Sorry, I'm going to have to change that. Don't worry, kids. the sum of the square root, sum of the square, it's not square root, so the square of two legs of a right triangle equals the square of the hypotenuse. You will never have to write this out again, by the way, just let's get it. Sum of the square of the two legs of a triangle equals the square of the hypotenuse. Which means this, ladies and gentlemen. First of all, you have to know this is a right triangle. This does not work with any other triangle but a right triangle. If you know that this side is 3 and you know that this side is 4, you will always be able to figure out what this side is. And it works like this. You square both of these sides. By the way, we have to identify there. These two short sides, the two short sides of a right triangle are called the legs. They are the legs of the triangle. They form the right angle. This long side here is called the hypotenuse. It is always the longest side. It is always opposite of the right angle. And what the little Pythagorean theorem states is that when you take the square of one side, one leg, and add it to the square of the other side, you get the hypotenuse squared. Which means this. What is 3 times 3? 9. What is 4 times 4? And that equals the hypotenuse squared. 9 plus 16 is 25. That equals the hypotenuse squared. What number times itself gives you 25? 5. So h equals 5. By the way, h equals, it's probably better to write this, h equals the square root. Let's do the square root of 25 first. But fortunately for us, there is a square root of 25, and that is 5. And that means this. That side is 5. Now, you have heard of this whole theorem before when you have heard this. And I know you've heard this, everybody, even if you heard it only in 7th grade here. The Pythagorean theorem is this. It is a squared plus b squared equals c squared. That is the Pythagorean theorem. That is what formula you always use for the Pythagorean theorem. And you have to make sure that you understand that a and b are always the legs, and c is always the hypotenuse. To which you might say, so what? Say, so what? But I can tell you the Pythagorean theorem is probably the most widely used mathematical formula of all time, because anybody that is in construction, anybody that builds buildings, uses this on a daily basis. For what reason, you ask? Well, if you are looking to make sure that two walls form a square corner, you know, how would you do that? If I said, if you're building a house and you were laying the foundation, which means you dig the hole and you put that trench in there so that you can form, you know, you put your house on top of a foundation which is made out of concrete walls or whatever, how would you ever know if the walls that you're trenching out, you know, you're sitting there, you know, you've got the ground. How would you ever know that if you build the trench, you know, you're digging into the ground this way, and then you dig into the ground this way? How would you know, because houses need to be square, how would you be able to figure out if that wall is square? Especially when it's so big. Well, they use the Pythagorean theorem. Okay, it is, we know that this is 3, this is 4, and then the diagonal would have to be 5. But not only is it just the 3, 4, 5, okay, you can use ones that are proportional to that. In other words, if I multiply everything by 10, you could use a 30 by 40 by 50 triangle, which if you're doing a house, you know, if you have this wall here, you can make this wall any way you want. Okay, you can measure out 30 feet from here to here. Okay, and then you can make this wall or plan out your wall this way. If you go 40 feet out there, then you know that this diagonal line that you're putting in right here has to be 50 feet. And if it's not 50 feet, let's say it was short, let's say you only had 48 feet, you know you don't have a right triangle. You just keep meeting these out till you get these two measurements to meet up at this exact place. Yeah, okay, you don't care. If you're ever in construction, that would be it. Now, ladies and gentlemen, here is the deal with this. What if I wasn't using 3, 4s, and 5s? What if it was, let's say I have a right triangle, and I know that this is 2 feet, and I know that this is 5 feet. How long would this be? What is going to be your steps, Brady? The first thing you're going to do is draw the triangle. Second thing you're going to do is label the triangle. Third thing you're going to do is write down the Pythagorean theorem, which is a squared plus b squared equals c squared. And then I'd strongly recommend putting parentheses for the letters. This squared plus this squared equals c squared. And it doesn't matter which one you actually call which one it is, it doesn't matter. You put a 2 here and a 5 here. What is 2 squared? 4. What is 5 squared? And then equals c squared. What is 4 plus 25? 29 equals c squared. Now that doesn't help me a bunch. Let me write it over here so you can see it. 29 equals c squared. I want to know what c equals. What does c equal? What number times itself gives you 29? Riv? You don't have one. So this is what you actually write down. C equals the square root of 29. Now there's not a perfect one. There's not one that works out nicely, but you should be able to estimate, Charlie, the square root of 29 would fall between what two numbers?
32.
Well, think about what two perfect squares 29 falls between. It falls between the square root of 25 and the square root of 36. What is the square root of 25?
5,
The square root of 36.
6.
So this has to fall between 5 and 6. Okay. But if you're doing the math, you're just going to say it's the square root of 29. Got that? Got that. Let me give you another one. Boom. Boom. Let's say this is 7 inches and this is 21. No, let's not do 21. Let's do something easier. Let's say this is 11 inches. Again, you're going to do the same thing. It has to be a right triangle. You're going to write down a squared plus b squared equals c squared. 7 squared plus 11 squared equals c squared. 7 times 7 is 49. 11 times 11, anybody in your head? Thank you, 121 it is. Equals c squared. 121 and 49 is 170 equals c squared. What does c equal? Ephraim? No, c squared equals 170. I want to know what c equals. Have you caught on to this? It's always going to end the same.
Square root.
Square root of 170. And you can leave it as the square root of 170 if there is no. Is the square root of 170 a perfect square? Some number times some number give you 170? No. 20 times 20 is 400. 10 times 10 is 100. 12 times 12 is 144. 13 times 13, what? 169, I think. So it's going to be awful close to 13. You can just leave it as this. C equals the square root of 170. Now, in case you haven't picked up on this, there are not a lot of right triangles that work out perfectly, like the 3, 4, 5 one we did. There's only a few that work out perfectly. And you will see the ones that work out perfectly right here. Ones that work out perfectly are called the Pythagorean triples. They are the ones you want to see because they work out nicely. You have the 3, 4, 5 triangle, which is one we did. The next one you have is a 5, 12, 13. Now let's take a look at that one just so you can see that. If you have a right triangle whose one side is 5 and the other side is 12, if we use the Pythagorean theorem, a squared plus b squared equals c squared, 5 squared plus 12 squared equals c squared. What's 5 squared? What's 12 squared? If you add 144 and 25, you get 169. And believe it or not, ladies and gentlemen, 169 is, well, the square root of 169 is, 169 is 13. It works out nicely. Okay. As does 8, 15, 17, 20, 21, 29, 9, 40. These will all work out nicely. Okay. But, Riv, don't think that these are the only ones there are. Because like I said, when you're looking for triples, let me go back to my 3, 4, 5 triangle. If this is 3, and this is 4, and this is 5, this is like your base triangle. You have an infinite amount of other triangles using this as your base that also work out with these numbers and proportions. In other words, if I multiply all sides by 2, instead of a 3, 4, 5 triangle, I would have a 6, 8, 10 triangle. That is also a Pythagorean triple. 6 times 6 is 36. 36 and 64 is what? 100, which is 10. Or you could multiply them all by 3. A 9, 12, 15. 9, 12, 15 is also a Pythagorean triple. As would be, if you multiply all those by 4, it would be 12, 16, 20. Okay? So you have to recognize that and see that when you're dealing with these, that these are all the base ones, but for every base one you have an infinite amount of ones that are proportional to it. Now here, let me give you the example of this. If this was 18 and this was 80, will this work out perfectly? You look up here and you go, well, there's no 80, 18 one. Okay, but when you look at these numbers here, you have to think about like if they were a fraction. If this was a fraction, could I reduce those numbers?
Yeah.
What could I do to both of them?
Even and non-even.
Cut them in half, right? And if I cut 18 in half, I get 9, and I cut 80 in half, I get 40. Is there a Pythagorean triple that is 940?
Yes.
What is its opposite side? 940, 41. But my answer to this is not 41. That's the reduced triangle. To get back to the original triangle, because I cut these in half, 8 and I have to double.
Multiply by 2.
Right, which would make it 82. Okay? You get that? It's something you got to get used to. It's not only the triples, but it's also their ratios or proportional higher ones. And, ladies and gentlemen, don't forget that this also might happen. Every triangle we have done so far, I have given you the 2 legs. But that's not always going to be the case that they give you these 2. You might get a hypotenuse and a long leg. For example, I might say this is 100, and then I might say this is, let's just go 75. How long would this side be? Well, Brady says, the first thing I would do besides sketching the triangle and writing down the dimensions would be to write the formula, which is
a squared plus b squared.
Now in this case, which one don't I know? In this case I do know what c squared is. Well, I know c is this, so that's 100 squared. It doesn't matter if you put 75 to be either one of these letters. A lot of times we put b to be the longer one, so I'll put 75 squared there. And that equals a squared. How do I figure out what a squared is? Unfortunately, ladies and gentlemen, what is 100 times 100?
1,000.
It's 1 with 4 zeros after it. What's 75 times 75? I guess we'll have to do that now. 375. What is it?
7,750.
Did you do it already? Huh? Are you guessing? Is that what it is? I don't know. How did you know that, Rib? Maybe you should be up there teaching. 49 plus 2 is 52. I get 5,625. You're just guessing at 7,000? I'm sorry, this should have been plus. So a squared plus 5,625 equals that. How would I figure out what a squared is? I don't know, we haven't actually done this before, so maybe I should skip that and do whatever there. I should have done easier numbers. Well, maybe they don't. Maybe this comes up later. Maybe I don't want to do this with you right now. Yeah, let's not do that. Because it's solving equations that we haven't done. Wow. Well, anyway, that took a lot longer than I thought. You say you do have scissors? I might be able to find 2 or 3 pairs for you. What you're going to do is this, ladies and gentlemen. Let's see if I can find this. I am going to give you this piece of paper that has this. Here, you are going to prove the Pythagorean theorem for me. Okay? In other words, this. I'm going to give you a piece of paper that has this triangle on it, and it has these triangles on that. Okay, what we're saying is this. If you take this and square it, which is what this is a square. This is a times a. We're getting the area of this. And you take b and square it, which is this, the area of this. Oops. You should be able to, here is your goal, your job, your whole assignment, wait, where'd it go, is to take and cut out all of these triangles and rearrange them so that they form a square that has this as its side. So it'll look like this when you're done. It runs out of my paper. But you'll get a perfect square here. That is, when you add these 2 squares together, you get that 3rd square that has the side length of that hypotenuse. Ooh, you're supposed to say, ooh. Ah.